Assalamu alaikum wa rahmatullahi wa barakatuh, and hello everyone. In the previous video, we covered the functions and variables topic in clean and how to use them. And in this video, we have also something related to functions, which is called function signatures. You may ask, actually, what is a function signature? And for that, we need a quick recap. Okay, quick recap. So we know that a function takes an input and it provides an output, and we learned how to use that in the previous video in clean. However, we can be a bit strict to specify the type of input that the function takes and the type of output that it provides. So a function, in theory, can take anything. It can take a text, English text, and it outputs, for example, a German text. We don't know. It can output an image. We don't know. So it also can take a number and output a string. We don't care. But we have the authority to specify the type of input and the type of output that the function should be used with. So if we're going to use a function, we must use it, for instance, with a specific input, a specific type of input, let's say a number, and it will give us specific output, which is, let's say, an image. So we give it 1, it gives us an image that has one drawn inside it. Again, a type can mean anything. It can mean a string, a text, an English text. It can mean an image, it can mean a number. And a function signature is a way for us to define the inputs, the input type of the function and the output type of that function. And without further to say, let's go coding. I already went ahead and created a new file for this video, and same as always, put the module keyword on the file name, and don't forget to import the std environment stuff. We will understand why in the next video. After that, let's create a simple function called anyInputToTextTransformer. This function takes an input and prints it as a string or a text. First of all, let's transform the given input to a text by using the built-in function in clean that is called toString. This built-in function allows us to transform any value to a text. So we use it to transform the value of the input to a text, then we store the result in a variable. Remember, you can name the variable whatever, but I decided to call it input as text format. After that, let's combine both the this is as well as the result of the transformation which we already stored in a variable. To combine both strings, we can use the +++ operator which clean provides. Now let's create the start function of our program and then try it out with our function. Let's try it first with a number and see the result. And as you can see, the result is 3. Let's try it with a character, then with a text. It works for all cases. Note that clean has multiple built-in types inside it. So it understands what is a number and what is a text and can differentiate between them. Another important information is that clean calls them differently. It calls the numbers as integers, it calls the text as a string, and so on and so forth. Also, clean can differentiate between the types based on how you write them. For instance, you can write a letter, a character, or sometimes called an alphabet, inside a single quote, and clean can understand that this is an alphabet, it's a letter. Same goes with text. So if you write some kind of English sentence between double quotes, clean can understand that this is a text. Again, to remind you, function signatures allow us to restrict a function to a given type. So let's illustrate this by giving an example. Let's copy our function and change its name to number_input_to_text_transformer, because I'll be restricting this function to take only numbers as input. Everything is still the same at this point. We haven't changed the new function. We can try out that new function by starting it multiple times with different inputs. Now let's start by creating the function signature. First of all, make sure that you are above the function you want to restrict. Then type the function name, double colons, the type of inputs, an arrow, then the type of the output. Another thing to keep in mind is that the number of input types in your function signature must match the number of inputs in your function. In our case, we created a signature that restricts the function to an integer type and outputs a string type. Notice that clean actually named the integer type by int. Now let's try to run our function with different types and see if it will work with integers only or not. First of all, let's try the text hi. It does not work, and we get an error saying that the function is expecting an integer and we gave it a string. Let's change the hi to a number 3 and try again. It works. Now for the last experiment, let's change the 3 into an alphabet or a letter instead of a number by encapsulating the 3 with single quotes. Now clean reads the 3 as a character, not a number. And we get an error, of course, because the function is only restricted to accept numbers as input, not characters nor strings. To demonstrate further, let's create another function that only accepts a character or a letter as an input. Let's copy the exact same function and then change the name once again. Then let's change the input type of the new function to a character type, or char as Clean love to call it, and rerun the experiment once again. And it will fail on all cases except when the input is a character. One last thing to keep in mind is that characters only consist of a single letter. Trying to write multiple letters in single quotes will give us back an error. Finally, to recap, make sure you are above the function you want to restrict. Then start writing the signature. The signature by default starts with the function name, then double colons, the types of the input, an arrow, and finally the type of the output. Okay, good job. So we're almost there. However, we need to understand why do we need this concept in Clean. Well, there are two main reasons for using function signatures, and the first one is that other developers can read your code and understand it with ease. So they read the signature and they understand how the function behaves. What does it take? What does it output? The other one, which is avoiding bugs in the future. So when you use a function signature, you restrict it at build time and make sure that the function is used properly with its desired types and it outputs the correct thing. And that's it for this video. Next video will be modularizing our code, and see you then. Goodbye. Ciao. Salam.